The AI coding reckoning. Linus Torvalds has never been one to sugarcoat, and at Open Source Summit North America, he delivered exactly the grounding the AI hype cycle needs. Asked about claims that 99% of code is AI generated, Torvalds pushed back hard. I literally get angry because those same people. I can pretty much guarantee that 100% of their code is written by compilers, but they never say that. His framing is precise. AI is a productivity multiplier on the order of 10x, impressive, but actually 100x less than the productivity gains compilers delivered over the decades. The real work remains understanding systems deeply enough to direct the tools. People who know what they're doing to understand systems will be able to prompt tools to write good code. People who don't understand the complexity of systems will also prompt systems and write processes that will fail. The maintainer burnout angle cuts deeper than the productivity debate. Torvalds described a surge in AI-generated pull requests ahead of Linux 7.1 release. More commits during preparation than any previous release. That turned out to be AI use rather than increased interest. For the Linux project with its resources, this is manageable. For the thousands of single maintainer projects, it is existential. Sometimes AI reports a bug, and when you ask for more information, the person has done that drive-by and doesn't even answer your question. Worse, some companies invest in AI bug finding for media attention without providing patches. Strangely, none of these came with a patch, even though all of these were in open source code. That productivity argument cuts differently depending on where you sit in the stack. A 10-year back-end engineer specializing in fintech, PCI compliance, double entry ledgers, payment idempotency, posted a remarkably candid account of watching each pillar of their expertise erode. Domain knowledge, Claude with a Sentry MCP one-shots bugs across distributed systems that used to take 2 days of full-time debugging. Debugging intuition, Opus 4.8 with the Datadog MCP handles 90% of production issues, including bizarre race conditions and undocumented API edge cases. The last remaining pillar, code architecture and quality, is being reduced to taste, and the industry is moving toward code bases optimized for machines to read, not humans. All my finance and payment domain expertise, all the debugging intuition earned through hours of sweat and tears, is now commodity. The post resonated because the author is not panicking. They are employed, productive, and clear-eyed, but the trajectory is unmistakable. One of the more ironic consequences of this shift. Programmers who spent decades refusing to document their code are now meticulously writing handoff documents, structured project summaries, and detailed Claude.md files. Not for their colleagues, but for the AI. As one developer observed, the end-of-project write-up takes 10 seconds instead of an hour, and the quality is roughly comparable to what a human would produce. The incentive structure that documentation advocates failed to create for 20 years materialized overnight, once the machine literally cannot function without externalized context. The training data dimension adds another wrinkle. A widely discussed experiment trained an LLM on 700,000 romance novels, expecting domain superiority, and the specialist model was less creative, more formulaic, and worse at basic narrative than a general model trained on the whole messy internet. The same pattern appears in code. Models that see unrelated material write better code because they have learned the shape of more things. Surface area matters. The weird stuff in the training data is what stops the model from becoming a parody of itself. Agent orchestration's new frontier. The question of how to structure AI-assisted development has moved from philosophical taxonomy to shipping infrastructure. Reuven Cohen's framework, skills, agents, and harnesses, captures the maturity ladder most teams are climbing. A skill is a markdown file with instructions, lightweight and shareable. An agent has goals and invokes tools. The harness sits above both, providing persistence, memory, governance, routing, verification, coordination, and learning. The model generates tokens. Agents perform work. The harness creates outcomes. The distinction matters because enterprises that skip the harness layer build agent demos, not agent systems. Claude Code's dynamic workflows, branded Ultra Code at the highest effort level, represent Anthropic's answer to the harness problem. Instead of a static one-size-fits-all approach, Ultra Code builds custom orchestration scripts on the fly, spawning potentially hundreds of agents with isolated context windows and focused goals. The patterns include classify and act, fan out and synthesize, adversarial verification, and tournament-style evaluation. A built-in deep research workflow ran 101 agents, consumed 3.7 million tokens, and completed in 11 minutes. A bug hunt workflow on a Next.js codebase found 34 confirmed bugs, with 7 false positives identified by adversarial verifiers in half that time. The key innovation is not the agent count, but that each agent gets a fresh context window, combating the agentic laziness, self-preferential bias, and goal drift that plague single-session approaches to complex tasks. Ultra Code lets Claude Code decide when a task needs dynamic workflows versus the static harness, removing the user from that routing decision entirely. The multi-vendor dimension is getting tooling too. CC Fleet is a Go CLI that spawns any vendor LLM. DeepSeek, GLM, Qwen, Kimi, Minimax. As real Claude code teammates running in Tmux panes, driven via native team create and send message. Your main session keeps its own auth. Vendor workers build the vendor API key via secure API key helper that never touches invars or shell history. The architecture is pragmatic. Use cheap models for commodity tasks, reserve frontier models for complex reasoning, and coordinate them all through Claude Code's native teammate protocol. GitHub's agentic transformation is the industrial-scale version of this same shift. In a wide-ranging interview, GitHub engineering leadership described 17 million PR agents in March alone, services seeing 3x expected growth, and a data center maxed out with load shedding to Azure. The design team is exploring AX, agentic experience, where bidirectional canvases let agents read and modify the UI while users interact through the same surface. The low-floor, high-ceiling philosophy aims to lower barriers for new builders while raising what professionals can accomplish. On whether humans remain necessary, we named Copilot Copilot for a reason. Meanwhile, the Agentics Foundation, an open-source community that spent over a year meeting on Zoom, held its first in-person gathering in Budapest. 5 days of workshops, conference presentations, and an open mic night. The recommended focus for next-generation engineers: critical thinking, collaboration, communication, and creativity. Lion AGI takes a different architectural stance. Agents as runtime-composed configurations with reactive signal processing and typed capability namespaces. Its Kive graph runtime, written in Rust, handles memory, knowledge graphs, and multi-embedding retrieval, while a custom inference engine called Lattice claims twice the speed of llama.c, p for tiny models. The governance model is strict. If a structured output type is not pre-configured and granted, the system simply ignores it. No exceptions. The framework can orchestrate Claude Code, Codex, and Gemini Code as subharnesses, treating external tools as composable execution backends rather than competitors. Zero Trust meets the agent supply chain. Anthropic published a practical security framework for deploying autonomous AI agents in the enterprise, built on zero trust principles. Trust nothing, verify everything, assume breach has already occurred. The guide addresses threat vectors specific to agentic systems. Tool access, autonomous decision-making, context persistence, multi-agent coordination, prompt injection, tool poisoning, identity abuse, memory poisoning, and supply chain attacks. It maps a 3-tier architecture: foundation, advanced, optimized, to organizational maturity, with an 8-phase implementation workflow covering identity, access scoping, sandboxing, input/output controls, and memory safeguards. The core thesis is sharp. Frontier AI models are compressing the timeline between vulnerability and exploit from months to hours, and organizations deploying agents face this acceleration twice, once on their infrastructure and once through the agents themselves. The organizations best positioned are those whose fundamentals are strong enough that AI-assisted scanning finds fewer bugs in the first place, and whose agent deployments are architected for breach from day one. On the supply chain side, Perplexity open-sourced Bumblebee, a read-only inventory collector for developer endpoints that answers a narrow but critical incident response question. When an advisory names a package, extension, or version, which developer machines have it installed right now? It is a single static Go binary with 0 non-steadlib dependencies, 3 scan profiles, baseline, project, deep, and coverage spanning NPM, PyPI, Go modules, Ruby gems, Composer, Homebrew, editor extensions, browser extensions, MCP host configs, and agent skill lock files. Feed it an exposure catalog and it flags exact, ecosystem, name, version, matches. The threat intel directory ships maintained catalogs built from public threat intelligence reporting on recent supply chain campaigns. The design philosophy is deliberately narrow. Read-only, no package manager execution, no source file reads. SBOMs tell you what shipped. EDR tells you what ran. Bumblebee tells you the messy local state across lock files, package manager metadata, and extension manifests that neither of those captures. Autonomous AI research and self-improvement. Google Cloud AI Research's Scientist-owned paper introduces Chain of Evidence, CoE, a verifiability framework for autonomous research that treats every claim the way ACID treats database transactions. Each must trace through a recorded evidence chain to a grounding source. The system's pipeline. Problem Investigator reads up to 100 full-text PDFs per topic. Discovery Engine, parallel explore-exploit search tree, and paper writer with claim verifier. Maintains evidence chains by construction rather than retrofitting them at paper writing time. In an audit of 75 papers from 5 autonomous research systems across 5 frontier tasks, every baseline exhibited systematic integrity failures. hallucinated reference rates reaching 21%, score verification passing in as few as 42% of papers, and method code alignment ranging from 20% to 80%. Scientists achieved 0 hallucinated references, 0 of 337 bibliography entries, perfect score verification, 12/12ths, and the highest method code alignment, 14/15ths, while matching or exceeding human expert performance on all 5 tasks. On ML-eBench, it earned gold on 3D object detection, where a competing system scored 0.0000, and achieved state-of-the-art on the live parameter golf competition with novel techniques including Hessian diagonal-weighted SVD initialization. The project website showcases 21 autonomously generated papers with all references verified against real publications and every claimed result reproducing under reevaluation. SIA, self-improving AI, from Hexo AI approaches the problem differently. A meta-agent generates an initial task-specific agent. That agent attempts the task. A feedback agent reviews performance and updates the agent, and the cycle repeats across generations. The paper reports a 56.6% gain on LawBench, reaching 70.1% top 1 accuracy versus 45% prior SOTA, 91.9% runtime reduction on GPU kernels, and 502% improvement on single-cell RNA denoising. It supports multiple agent implementations. Claude Agent SDK for Anthropic models, OpenHands for multi-provider, Gemini, OpenAI, Anthropic, and ships with a built-in web dashboard for visualizing per-generation target agent code, improvement plans, and accuracy curves. At the opposite end of the rigor spectrum, a YouTube presentation claims to have derived the formula for intelligence itself through multi-embedder systems where meaning emerges from vector positions across parallel embedding spaces. What the author calls teleological constellations. The core technical idea, multimodal embedding constellations with Cassine similarity guardrails, is a restatement of joint embedding architectures, wrapped in claims of necromancy, divine powers, and future prediction via JPA world models. The presenter asserts AGI models can be compressed 9.099% and run on home computers, while simultaneously claiming the knowledge enables bringing the dead back to life. The contrast with scientist-owned methodology could not be sharper. One system audits every claim against its evidence source. The other presents extraordinary assertions with no reproducible evidence, no peer review, and no benchmarks. Agent-native infrastructure. CognoDB is an open-source, CYPHE, our compatible graph database written in Go, purpose-built for AI agent workloads. It speaks the Bolt protocol v5.0-5 Tor and works with all official Neo4j drivers, Python, Go, JavaScript, Java, .NET with 0 code changes. Cold start is 7 ms with 15 MB idle RAM compared to Neo4j's 17 seconds and 3.5 GB. The built-in MCP server exposes schema and query tools so any MCP-compatible assistant can query and write to the graph in natural language. The token economics are compelling. Agents that query CognoD for relevant context instead of dumping the full corpus into the prompt see token reductions from 62% at 185 nodes to 99% at 3,700 nodes, with costs staying flat as the graph grows. In a real LLM agent benchmark using AWS Bedrock, a 100-agent workflow saved $1.60 per run versus full context prompting. The trade-off is traversal latency. Neo4j's years of query optimization give it 3 MSP50 on 3-hop traversals versus CognoDB's 27.6 ms in memory. But for agent workloads, where cold start time and memory footprint matter more than raw traversal speed, the profile fits. Model regression takes aim at a different infrastructure gap. AI model providers update their models constantly, sometimes degrading performance without announcement. The project runs 30 tests daily against Claude Opus 4.8, Claude Sonnet 4.6, GPT-55, and Grok across 10 categories. Long reasoning, coding tasks, bug fixes, feature implementation, code thoroughness, bug introduction rate, security awareness, instruction following, code quality, and performance efficiency. Models are tested through their official CLI tools, Codex, Agent, not API calls, exercising the full developer-facing stack. Regressions are classified by severity: minor, 5% drop, moderate, 10%, major, 20%. The benchmark engine runs daily on a DGX at 3 a.m. ET, exports to static JSON, and deploys via Bluegreen to a next.js site. The live dashboard is at modelregression.com. On the model periphery, MisoTS appeared as a trending model on Hugging Face,
though details remain sparse at the time of writing.
Post-quantum web PKI. Let's Encrypt announced plans to support Merkle Tree certificates, MTCs, as its path to post-quantum authentication in the web PKI, targeting a staging environment in late 2026 and production in 2027. The problem is size. MLD-S-A44, one of the smaller NIS, T standardized post-quantum signature schemes, produces two 420-byte signatures. Roughly 10x larger than RS-A2048's 256 bytes and 38x larger than ECD-S-AP256's 64 bytes. A typical TLS handshake carries 5 signatures and 2 public keys. Replacing them with milliliters D-S, A equivalents would push past 10 kilobytes, where research shows a meaningful share of connections fail on real-world networks and the rest get slower. MTC sidestep this by issuing certificates in batches with a single signature covering the entire batch. Browsers stay current on batch signatures, landmarks, separately from the TLS handshake, so the common case authentication path is one signature, one public key, and one inclusion proof, smaller than today's handshake even with post-quantum algorithms. Transparency becomes a structural property rather than an afterthought. A certificate cannot exist outside the Merkle tree, eliminating the bolted-on certificate transparency ecosystem where certificates are issued by CAS, logged separately, and carry extra signatures as attestation. Cloudflare and Chrome are already running an experiment with MTCs against real internet traffic, and Chrome has indicated MTCs are its preferred path for post-quantum certificates. The timeline pressure is real. Google announced migration of its services by 2029, Go 1.24 added milliliters D-S, A to the standard library, and NSA directives would deprecate R-S, A2048 and P256 after 2030. As Let's Encrypt notes, nothing changes for existing subscribers today. Certificates continue to be issued and renewed exactly as before. But if you maintain an ACME client or run an Acme-driven certificate pipeline, now is the time to start tracking the IETF plant's working group, because some of the changes coming will require client-side support.